Now we're going to do an example where we're given a piecewise function. We're going to sketch the graph of that function and then use the graph to find some left and right-handed limits. Okay, so here's our function. We're going to sketch our graph. Okay, so the function says that it's negative x plus 2 if x is less than 3. I guess I should draw some lines here. Now, the x is less than 3 thing is interesting because that's basically where our graph is going to change. Okay, so we want to do negative x plus 2 when x is less than 3. Now let's start at 3. So if we plug in 3, we would have, so we can make ourselves a little table of values. So this is for x less than 3. We'll have x, and then we'll plug it into negative x plus 2. So at 3, we'd have negative 3 plus 2, which would give us negative 1. Since that's just a less than and not a less than or equal to, we're going to put an open dot there. Okay, now, this is just a line, mx plus b, and the slope is negative 1, which means it's a negative slope line. Okay, so that means we can go up 1 and to the left 1 to get another value. And there, up 1 to the left 1. And it's going to be like this. Except I didn't draw it very well because it should cross the y-axis there. Right, if we plug in 0, we get 2, so we get a line like this. Okay, then x is greater than or equal to 3. We're going to plug it into the second line. So if we plug 3 in there, we're going to get 1, and that'll be a closed dot because it's greater than or equal to. If we plug in 4, we're going to get 2, 5, we would get 3, and so on, and we'd have a line going that way. Okay? And now we can do just like what we did on the last video using the graph. So here we want to find the limit as x goes to 2. The left-handed, right-handed, and the limit. Now at 2, it's this first line, the negative x plus 2, because 2 is less than 3. Okay, and from both sides it's equal to 0. And so our limit is also 0. Okay, so we can see that at 2 the graph is at 0. Since 2 is less than 3, we could also, and not the place where it breaks, we could also just plug it in up here. Okay, now let's look at 4. Now 4 is above the part where it jumps. Okay, and we see the y value there is 2, or what happens if we plug it into the second line. And there, it's nice and smooth, nothing's happening. So our left-handed limit's 4, our right-handed limit is 4, and our limit is 4. And then now we want to look at 3, and 3 is this interesting place where the function changes, right? It changes here at 3. And that's where we really have to be careful. So when we're coming from the left, right, coming down here, the left-handed limit is at negative 1. When we're coming from the right, the right-handed limit is at 1. And since those are not equal, the limit does not exist.